There are moments in the history of exploration when a single machine ventures so far beyond the known world that it begins answering questions humanity never thought to ask. Centuries ago, wooden ships disappeared beyond the horizon, returning with maps that reshaped our understanding of Earth. Today, that role belongs to a spacecraft no larger than a small car, a silent traveler carrying humanity's curiosity into the darkness between the stars. For nearly 50 years, Voyager 1 has continued a journey that was never supposed to last this long. Designed in the 1970s with technology that now seems almost primitive, the spacecraft was expected to complete a brief tour of the outer planets before slowly fading into silence. Engineers believed its power supply would eventually weaken, its instruments would shut down, and its mission would become a remarkable chapter in the history of space exploration. Instead, Voyager refused to follow that script. Decade after decade, it continued transmitting priceless scientific data from regions of space no human-made object had ever visited. Every signal arriving at Earth carried information from farther away than any message humanity had ever received. As the distance grew into billions of miles, Voyager transformed from a planetary explorer into the first true interstellar ambassador. But with every new milestone came a deeper mystery. The farther Voyager traveled from the Sun, the less familiar its surroundings became. The environment beyond the planets was not an empty void as many once imagined. It was filled with invisible magnetic fields, energetic particles, immense pressure waves, and cosmic radiation moving through the galaxy in ways scientists were only beginning to understand. Each transmission from the spacecraft revealed that interstellar space was richer, more dynamic, and far more complex than anyone had predicted. Recently, renewed attention has focused on unusual behavior detected during Voyager's long voyage. While some dramatic stories circulating online exaggerate these events into claims of alien contact or secret discoveries, the real mission is extraordinary enough without adding fiction. The true story is one of engineering, persistence, and scientific discovery unfolding at the very edge of human exploration. To understand why Voyager continues capturing the world's imagination, we first have to return to where the mission began. The year was 1977. The space age was still young. Humanity had landed on the Moon only a few years earlier, and robotic exploration of the outer solar system remained largely uncharted territory. A rare alignment of the giant planets offered an opportunity that would not occur again for generations. By carefully using each planet's gravity like a giant slingshot, a spacecraft could visit multiple worlds during a single mission while conserving precious fuel. NASA seized that opportunity. Two nearly identical spacecraft were built. Voyager 2 launched first, followed a few weeks later by Voyager 1. Despite the numbering, Voyager 1 traveled on the faster trajectory, allowing it to reach Jupiter and Saturn ahead of its twin. The spacecraft itself was an engineering masterpiece for its time. Powered by radioisotope thermoelectric generators that converted heat from decaying plutonium into electricity, Voyager carried cameras, magnetometers, plasma detectors, cosmic ray instruments, and communications equipment capable of transmitting faint radio signals across unimaginable distances. Its onboard computer possessed less memory than even the simplest modern electronic devices. Yet every component was built with extraordinary reliability, designed to survive years in the harsh vacuum of space. No one imagined it would still be operating almost half a century later. When Voyager approached Jupiter in 1979, it forever changed our understanding of the largest planet in the solar system. Scientists expected impressive photographs. What they received was something far greater. Jupiter emerged as an active and violent world dominated by immense storms larger than Earth itself. The Great Red Spot revealed layers of atmospheric complexity unlike anything previously observed. Lightning flashed through towering cloud systems with incredible power, while radiation trapped within Jupiter's magnetic field created one of the most hostile environments ever encountered by a spacecraft. Then came one of the mission's greatest surprises. Io, one of Jupiter's moons, was discovered to be volcanically active. Massive eruptions blasted sulfur-rich material hundreds of kilometers above its surface, proving that worlds far from the Sun could remain geologically alive. It was the first active volcano ever observed beyond Earth. Almost overnight, scientists realized the outer solar system was far more dynamic than anyone had imagined. Voyager continued collecting enormous amounts of information as it flew through Jupiter's powerful magnetic environment. Instruments measured streams of charged particles, fluctuating magnetic fields, and complex plasma interactions that researchers would spend decades studying. Many observations matched existing theories. Others raised entirely new questions. The deeper scientists looked into the data, the clearer it became that Jupiter's magnetic system behaved with astonishing complexity. Interactions between the planet, its moons, and the solar wind produced phenomena that challenged many earlier models and inspired entirely new areas of research.